Welcome back to another video on my channel, math_exe. Today we're going to look at some divisibility problems that you need to solve using modular arithmetics. This is like another trick to solve some divisibility rules type of problems other than the one on the divisibility rules video that I have posted a few days ago. So anyways, for question 1, find the possible values of a first case of part A if the digit 5a2 is divisible by 6, or we can just say that something like 6 divides the digit 5a2, something like this. For a number to be divisible by 6, it must be divisible by 2 and 3. So we're going to look at both of those cases. So for 5a2 to be divisible by 2, the ones digit must be a even number, and in this case it's true because we have 2 on the end. So this case checks true. For it to be divisible by 3, the sum of the digits must be divisible by 3. And we can just form a system of kind of like a congruence equation, I would say. So let's just write the sum of the digits of this number. So 5 plus 8 plus 2 is congruent, written by this 3 line sign, similar to the equal sign but not really. And it must be congruent to 0 mod 3. Or in other words, it leaves 0 remainder when it is divided by 3. And the left hand side simplifies to 7 plus a congruent to 0 mod 3. Alright, and first notice that 7 is congruent to 1 mod 3. And to maintain the equality, a must be congruent to negative 1 mod 3. Or if you are uncomfortable with negative remainders, this is just the same as congruent to 2 mod 3. Alright, so let's write what we have reached. So we got that a must be congruent to 2 mod 3. And keep in mind, there are a finite number of solutions to this problem, since we suppose that a is a digit. And what I mean by digit is a must be an integer between 0 and 9. And we can look through these integers and see which ones, when divided by 3, has a remainder of 2. And the possible values of a is either 2, 5, or 8. Those are the 3 possible solutions for this. And if you can just substitute each corresponding a value to the original digit, I mean the original number, you can check that it's divisible by 6. Alright, so that's the answer for part A. Part B, let's see what we have. The digit 8, 9a is divisible by 9. So we can just write 9 divides 8, 9a. And for a number to be divisible by 9, the sum of the digits must be divisible by 9. Or in other words, 8 plus 9 plus a, the sum of the digits, must be congruent to 0 mod 9. Alright? And the left hand side simplifies to 17 plus a is congruent to 0 mod 9. And notice that 17 is congruent to 8 mod 9, and therefore a must be congruent to maintain the equality. It must be to congruent to negative 8 mod 9 or congruent to 1 mod 9. Alright, so let's just see. Since we know a is a digit, we must find an integer that is between 0 and 9. That when divided by 9 leaves a remainder of 1, and that is just simply 1. So our possible value of a is just 1 in this case. Alright, so that's for the first example of this. Let's get into a second and probably a bit interesting the second question. So it says that all possible positive integer values for x such that the expression 4 plus 3x is divisible by 7 can be written in the form of x equals a k plus b, where a and b are positive integers, and then we really don't know about a and b yet, and k is a variable that can be replaced with any non-negative integer. So if you, for example, if you want the first value of x, probably you set k equals 0 probably, and that's basically how k works in this case. So we need to find a plus b. So knowing that 7 divides 4 plus 3x, or 4 plus 3x is divisible by 7, we can form we can rewrite 4 plus 3x as a congruent mod 7. So we have 4 plus 3x is congruent to 0 since it leaves no remainder, and then we're looking at mod 7. And notice right here that 4 is congruent to 4 mod 7, and to make this to make the left and right side equal in congruence, we need 3x to be congruent to negative 4, or it will be congruent to 3. If you are not comfortable with negative remainders, you may choose 3, which is what I'm going to choose. So we have 3x is congruent to 3 mod 7, and then we can divide by 3 on both sides, since the number we're dividing with is co-prime with the mod. And then you can just search on YouTube or Google or any source about why this is true, and there's probably a proof about that. So anyways, we're left with x is congruent to 1 mod 7. And from this point you may write some possible values for x. So for example, x could be possibly 1, 8, 15, and so on. And then from this you can find you might notice this is like a arithmetic sequence, and then therefore you can just find the kth term, not the nth term in this case, because k is the variable in this case. Or you can just rewrite x as something like this. So if x is 7, obtained from this 7, times whatever variable, possibly k, plus 1 right here. So in this form, 7 is the divisor, the modulo that we are looking at. K is the quotient that we don't really know about yet. However, we can just replace the quotient as k, which is a variable that can be replaced with any non-negative integer, and 1 is the remainder. So basically right here we just set x as something like quotient multiplied by divisor plus the remainder, something like this. And by suiting terms and coefficients, we know that a is 7 and b is 1. And therefore a plus b will be 8. This is the final answer for this problem. And I think that's it for this video, so hopefully you guys enjoyed this. Please subscribe for more videos and I'll see you guys in the next one. Goodbye.